All right. Hello, everybody. Welcome. Okay. Audio looks like it's working. Camera looks like it's working. I think we're doing okay. I didn't have a whole lot of setup time. The tweets were obviously very last minute. So welcome if you've made it. Sorry for the lack of heads up on things. But we're here. We're here for another Binders live stream. We have all sorts of good stuff to cover. And I'm going to try to be kind of quick today. I can't do too long because I've got to... what do I have to do? Something with my kids. I don't remember now. It's on my calendar. I'm supposed to get out of here and... Oh, my son's got a basketball game. That's what I got to go do. So I'm going to go see his basketball game for a little bit. But hey, Pierre, thanks for hopping in. Yeah, so I guess let me see. Let's get into it. And you know what? I realized I don't know if the Stream Elements... Okay, yeah, Stream Elements is working. Sweet. So let's see. I think this is my... Why is the browser not working? Launch browser. Command Shift Enter. Command Shift Enter. Box, welcome. How's it going? So I'm not sure why, but Firefox is not loading for me. So there we go. We'll do it. Oh, I think it did eventually load because I got 2 tabs. That was weird. All right, yeah. So this is I'm good, Firefox. Thank you. Oh, I think I just set this VM up, actually. That's right. Did I even... Okay, I got Binja on here. That's the important stuff. Nordgaren, welcome. Apologies if I mispronounced it. I see a couple new names. That's cool. So let's see. What are we doing today? We are going to... First, we'll cover some Better Ninja news, which I can probably just get off the blog, the last couple things. First of all, 3.3 was launched last week. I would love to see how many... I'm curious if anybody watching, if y'all are familiar with Dune, the desert planet. Obviously, there's a movie now with the book, the Frank Herbert book. There's lots of good puns and references in in this blog post. So I'm curious how many you can see. Fox, how's it going? We're gonna do. No, I'm just kidding. We're not doing Crazy Bomb. Not yet. It's gonna happen. A couple more years. You know, I gotta like warm up to it. So I need a few more years of stringing you along. So yeah, the 3.3 release is all like Dune themed. Although the funny thing is, I actually included the reference on Twitter, but I didn't put I didn't put the image in the blog post, which is kind of a bummer. I should also put it there. I'm good, thanks Twitter. But I love that like it was a Dolly generated image. You can see a little logo down there. Um, but it took a little bit of work because Dolly really wanted to draw eyes on the worm. I literally said eyeless sandworm or eyeless giant worm, no eyes, and it still kept drawing eyes. And so finally they've got a new mode now where you can just erase the eyes until it like generated one without eyes finally. So awesome, sweet. Glad to hear it, Norgaran. So now I've like forgotten if I said it differently the first time. So hopefully that was still it. So the worm. Anyway, I thought it was a fun little image. But there's also a bunch of little subtle references all throughout here, like a couple of the screenshots. Some variables have been renamed, and then there's a few other little hidden stuff. Welcome. Oh, I know who that is. How's it going, Mike? At least I assume from your name. Did I don't want to out you on stream unless you're okay with it. And I can talk about our shared thing that we do together, but I always like to ask first. So if you're cool with me talking about that, let me know. But no worries if not. So yeah, we're looking at the blog post. I dare you to find every reference you can in here because some of them are actually kind of subtle. So new release, I was exciting. We were excited internally because this was the first release, I think, that it was like just the most smooth, flawless release we've had in a while. We actually had a couple of we did have a couple of little whatchamacallits, like bug fixes the last like week of testing, but we like it was right on schedule. All of our testing was early enough and everything was nice. So I was really happy. Oh, that's funny. I just noticed that when you go to Victor 35's Twitter page, you might like, and it shows Ilfak, Alex Ionescu, and Gitter Ari. That's hilarious. That's really funny. Sweet. Yeah, I figured. I just wanted to make sure. So okay. So yeah. So um, and Wales and I have been like coaching a high school slash middle school CTF team. And by coaching, I mean he does a bunch of work and I show up and talk sometimes. So he's doing all the real work. Oh no, I forgot to turn Do Not Disturb on, obviously. So let me turn my phone on there. Do Not Disturb for 1 hour. Let's try that. So yeah, like that's been fun. We've been doing that, and like I said, he does a whole bunch more prep work, getting things ready, running little mini challenges, and it's been super fun to get some youth excited in to capture the flag and reverse engineering and vulnerability research and all that good stuff. So yeah, that's been enjoyable. Let's see, other bits of news. Oh, this okay, this might actually be important. I apologize. I'm gonna go take this call real quick, just to see. So I'll be right back. I'm sorry. All right, sorry about that. If somebody calls twice, I just figure I think the auto do not disturb if they're on my contact list will automatically let them through if they call twice. So yeah, the high school teams, kids in general these days, right, Joe? Like we get to be old men now and complain about. Also, welcome to stream this week. But yeah, we get to complain about how good they are and all the opportunities they had that so many CTFs and really cool events that they get to learn on. So oh, I know what I was gonna do. I was gonna go back to the blog. Welcome, Kai. How's it going? Now you got it. You got plenty of time. We got a good crew here today. We're still doing just like the news, the kind of overview stuff. So we've got the 3.3 release. We've got the reverse engineering survey. If you haven't already taken it, please do it. You can win some cool stuff. But also the survey is really useful. So if you actually remember last year, well, I guess over a year ago now, we even said something about in one maybe it was the tweets. A couple of things I remember writing up we said how it's like it's supposed to be a yearly survey. We just don't do it every year exactly. But this was like some of the summary information from the survey in the past. So we try to put out a bunch of details about what are people doing for the reverse engineering, and how experienced are they. And this was actually, yeah, this was the takeaway last time, was that surprisingly engineers are relatively humble. Like if you actually look, about what people, the Utes, that's right. You gotta say it with the proper New Jersey accent to be my cousin Vinny, the Utes. uh, there was a normal distribution of experience, which normally if you ask people, are they beginner or whatever, like you'll kind of skew heavier. People think they're better than they are. Is it Dunning-Kruger, I think, right? Is that the name of the bias or whatever, cognitive bias? Um, I just realized that sidebar looks not very good with a white background. I guess I'm just too used to like it being a terminal or Binja where it looks better, but it looks pretty bad here. Um, the chat box on stream. Anyway, so we actually saw like a reasonably normal distribution. We got a little bell curve there, so that was kind of interesting. So we'll, as soon as we've got all the survey results from this year, we'll put it out. We have a bunch more bits of information that we've asked for people. Some of it's about Binary Ninja, so if you've got experience with Binary Ninja, and a lot of it's just generic reversing. So please help contribute to that. We appreciate it. Like I said, you can get to it from the blog, and of course on our Twitter or our Mastodon, which are both linked down here, whichever you prefer. So, and of course, I know some of you all following it because I think some probably found the live stream today via those alerts, and of course following. So, all right, 1, 2, 3. Those are the news things. Oh no, third one. The third thing, which I didn't yet cover, so let's go back over here, is our trainings. So we've actually been amping Kyle. Yeah, exactly. I think I just need to have like a lighter dark mode for it. I could probably tweak it. Yeah, I can play with it later. It's not a big deal. And again, as soon as I'm done with the browser here, I'm gonna be in Binja in a terminal where it looks great the way it is now. So I'll probably just mess with that later. Yeah, there's really no point in being it super translucent, is there? Now that I think about it, because even like if Binja's there, you can't really see through it. Let me see. Um, let's see. Binary Ninja. Let's go dev. I think even if you have a Binja box, it's not like you can read anything behind it, can you? Let's open up something and put some text behind it. I still don't think it's all that readable. So at this point, I might as well just make. That's not true. I guess you can see like the scroll bar a little bit. Yeah, exactly. You've got chat for here. It's fine. In fact, half the time I turn it off. I have finally started capturing the desktop feed separately from my face overlay and the chat overlay, so that way we got like clean audio and video to be able to like snippet out stuff for the YouTube channel. So that was my most important thing is having that. But anyway, back to this. The training events, we have some new trainings that we're doing. This is like specifically for people who have companies, because I don't want. We've actually had a couple people who like pay out of pocket to take our trainings, and that always actually makes me sad because they're really expensive. They're several $1,000s for the training classes. At some point, I'd like to do a like self-study online pre-recorded video version of it where we don't have to like charge as much. And people could take it kind of at their own pace. So that's one of our goals, to polish off a couple of our trainings and do that with. But we've got several different things happening now. There is 2 new ones that Vector 35 is putting out. And of course, we've got several that we're doing with Sophia. We love doing that course. That's a really advanced one. Now you're good. It's all good. I take myself off topic anyways. I'm easily distracted, and I honestly kind of like bouncing from topic to topic. I get bored if I was doing the same thing. So, although it does make it harder to snip it out and pull out those videos that I was mentioning when we're trying to edit things, and you got to like assemble the random things I was saying. But if you're actually doing video editing though, Descript is your friend. It's a really pretty sweet piece of video editing where you can literally grab text and delete the text, and it just edits the video automatically. It's a really cool app, so that helps. But again, see, I told you I distract myself. So trainings are coming up. There's a bunch of them. We're gonna be at Offensive Con. We're gonna be at Recon. I just got back from ShmooCon. We had a whole bunch of t-shirts and stuff there too. So if you are going to either Offensive Con or Recon, I don't know if I have a family vacation, so I probably won't make it to Recon again this year, unfortunately. But definitely several other people from the company will be there. Kyle and Peter, I think, are both doing the training. Let me double check on that, but at least Kyle's going to be there, and we'll probably have some other folks. So definitely folks going to be at Recon. Uh, and yeah, some other new trainings coming up. So, okay, that's all three of my news topics. And now I got to go find my link because there is a, a what do I call it? There's like a thing I've been wanting to do for a while, and I've been taking some notes on called like Once More with Binja, where I take, actually, I think it's still on the front page, where I just go find random things that people have done with other tools and like redo it in Binja. Like, let's see what it would look like in Binary Ninja. Are there things that are easier or better or worse? And how would you accomplish the same goal? And so there's one here that I saw that I thought would be a really good one too. I was like, that doesn't look like reverse engineering. And then I realized that was promoted. That's actually kind of okay. It kind of worked though. That's a cool game graphics. Speaking of news, this is actually another good one too. So Synthesis, Tim Blazitko, is super, super smart. He actually has several trainings as well. If you do any kind of automated code deobfuscation stuff, check out his training classes here because he's great. You should definitely go look at his training classes. They're fantastic. He's gonna be hacking the box. Yeah, I like hacking the box, and he will also be at Recon. So that's the amount I'm missing there. Hopefully he'll be at Offensive Con even if he's not training there. So he did a recent blog post where he's got a Binary Ninja plugin. So in the plugin manager is the obfuscation detection plugin. And so this was just updated, you'll notice, a couple days ago. And this is the blog post that goes with it. This statistical analysis to detect uncommon code. And he just talks about like how you can identify frequency and sort of unusual opcodes, which is a good way to identify things that maybe are like packed or obfuscated, or in other ways, in other words, weird. So he shows a lot of it, but then you can also just run the Binary Ninja plugin that he built that does that. So that's a cool one. Tim's awesome. And there's that's a kind of neat plugin too. The IDA folks have released Goomba, which looks a little fun. I haven't had a chance to play with it yet. I want to see how it compares because I certainly some of the improvements it makes look really clean and nice. And some of it, like with our constant analysis, will actually fold too. But I think there's just some nifty things. So I want to play with that because that looked pretty fun. Let's see. Where did I thought it was on here? It was specifically on like code obfuscations. It wasn't Tim's post. There it is. Small tail of anti-RE. I think this is it. That's weird. What? Oh, because Elemental X2, I guess, is the username. That's interesting. All right, is this it? This is it. Okay, so here's the blog post I want to talk about, and we're gonna just kind of skim through it a little bit and talk about how Binja would have done better or worse, or how it works. I was a little bummed because he actually references Binary Ninja in the credits, the resources that he used. He talks about our old blog post of ours, but doesn't really mention it in the post itself, which is like, oh, come on, you missed all the good stuff. But this is kind of just a summary of, oh, hey, Amy, welcome. Sorry, I don't have my chat up on the monitor anymore. I missed that. Let me pull that back up so I don't miss it. Welcome. It's good to see you, Amy. I missed you at ShmooCon. I was hoping to see you, but hopefully you not having to travel was more relaxing. So maybe at Offensive Con or something else, we can catch up. Or DEF CON. Certainly probably DEF CON. So okay. This blog post I saw just talks about some simple ways you can do manual obfuscations, right? And so kind of explains the concept of linear sweep versus recursive disassembly. And we actually use linear sweep in a different way than is correct, or that is the normal understood version of the definition. No, that's all good. Like I said, I'm sure we'll have plenty of other times to catch up. So linear, I think I mentioned this on stream at least once before, but just to recap, the way the blog post describes it, recursive descent or recursive disassembly is you start at like the entry point, or you start somewhere, and then you just follow all the control flow. So you follow true branches, false branches, and you follow them until you're done, and you've found hopefully all the code. If you have perfect disassembly, and perfect ability to understand things you would, except for things like indirect control flow or bugs in disassemblers. Or there's just a lot of reasons you can get, like, virtual function tables can be really hard to statically analyze and identify possible code paths. Exception handling, there's a lot of reasons, things you can't just statically figure out the code paths to by just following recursive descent. And so linear sweep disassembly usually refers to the process of literally just byte by byte disassembling as you go, and hoping you're aligned correctly, because then you have to worry, like with x86 or a variable with instruction set architecture, obviously you have to worry about like misalignment and where do you start your disassembly and can you get misaligned, and weird stuff can happen there. But that technically you can find all possible disassembly if you do that, but you won't necessarily have it in the correct control flow. You won't necessarily have the relationships between it, and you have a bunch of garbage. You're gonna have a whole bunch of other junk. Yes, Sunghoon, welcome. I am one of the developers um, uh, of Binary Ninja. I like to say I'm the worst developer of Binary Ninja, because I think I am. We have really good developers. I'm just the one who talks about it on stream. So we actually have a number of people in our company that all work on different parts of Binary Ninja. I do write some of it, but I mostly get to like talk to people about it and customer problems and troubleshooting and do streams like this. But I build a couple things. Like, for example, the next thing I'm going to be working on is I want to go make some improvements to the plugin manager. I have some good ideas on stuff we can improve there. But yeah, welcome to Vector 35. Yeah, and so Vector 35 is the company that makes Binary Ninja. So linear sweep rate, obviously you're going to create a whole bunch of functions and blocks of code, but then you have to kind of figure out the relationships between them, and that still is hard without perfect analysis, and so it doesn't always work. Yes, thank you, Joe. I made snippets too, so if you're familiar with Binary Ninja, the snippet editor is one of my little bits of handiwork. You can tell I did that because it's a lot of Python. I don't write nearly as much C++ as other people on the team, although I have worked on the plugin manager before, but I keep my C++ snippet or amount of code changes relatively small. Yeah, so I do a lot with the API. So all right, so basically the blog post is talking about like how disassembly happens, how you can put just follow the control codes and follow things as they jump. Talks a little bit about sections in the binary, and then talks like, so this is where I don't really understand the purpose of this particular exercise, because it's literally just like doing some math on numbers. I guess it wants to show the values you get, but it doesn't actually do any kind of obfuscation at all, right? I guess that's the point, is there is no obfuscations, and they put some garbage code in, but there's also still, it's like putting nops in is not going to cause any problems, right? So again, that one doesn't really make sense to me as to why they do it. This one's a little more interesting, where there's like a loop that does nothing. But even still, I don't feel like it's going to really throw off anybody's kind of understanding of what the program does. So let's see. The logic of the program is exact. Yep, it does the same thing, except we've got this extra garbage, and there's a little loop in the middle, which is true. There is. So actually, this is kind of hard to. So this syntax, I think, here is Visual Studio. But fortunately, Binary Ninja has a built-in assembler, so I can just basically take all this, and we can just take the original disassembler, take the opcodes, and just assemble them in place. No reason to invoke the compiler at all. Since I think these examples are meant to be little tiny ones, they're not actually like inside of a normal. Wait, oh, that's right. We've got our counter up there. Okay, so because they're little tiny assembly examples, they're not actually using any real C. They're just this. So we're going to see what this one looks like, and then once I've done it once, it'll be a lot easier. Let's see if we get our syntax right. Cool. So, and then the nice thing about is if I trigger the assembly dialog again, it remembers by default the last little chunk of code I had. So I'm going to hit P to make an architecture, or make a function specifically. I could use another thing to make it just disassemble it, but I want to actually do some analysis and trigger it. It doesn't really hurt to do that. So if I disassemble this, you can see it gives us this question mark here because the code doesn't return, whereas the original sample, they were compiling this into a full binary and then disassembling it and decompiling it. So it makes, and they had the return at the end. So it would have been a different ending, but otherwise it's the same. Not a whole lot of differences here. And they've got disassembly that they're just showing it's a loop, which, yep, that's exactly what we're showing. There's nothing really different there, except we put the loop condition in the branch here when we're or put the loop address rather instead of lock. We do it as oh no, it's the same thing. We just don't do LOC in front of it. It's just the address, right? Because if I do Control P show addresses, or I in the drop down here click show address, you can see the addresses, and we're just looping back up to there. It's basically the same thing. And of course, our addresses are different because I'm just doing it in a little flat file. All right, so yeah, that doesn't really do a whole lot. I'm not going to debug it, but we could. And so here now, calls to a garbage subroutine. This is a little more complex. What is this one doing? Okay. So I looked at this blog post and I was like, oh, this looks good, but I intentionally didn't fully like read it all and try to like plan out in advance how I was going to handle things because I wanted to kind of do that on stream and make it a little more realistic. And also because I'm lazy. I don't want to have to prepare extra. But yeah, this way y'all can see me figure it out as we go and we can look it over together. So, I mean, the actual function here, is there a loop? So, all right, so they're implementing a manual loop by deck ECX and they don't use the loop instruction. That's really annoying when it does that. They're doing a loop instruction, or they're not using a loop instruction the way they were before. They're using just a conditional branch where the ECX is the counter. And does this subroutine do anything with ECX? Is it gonna like mess up analysis? Now, all right, so let's just take this. This doesn't seem right though, right? Because this is gonna put this subroutine after this original code. It's going to run it here, and then it's going to run it again before it returns, which seems a little odd. I feel like you want like a jump here to your return, or just return here. But anyway, let's try it. So we'll make a new one, and we'll assemble into that one. I'm not bothering with the exact syntax, but we're going to just do a call. So let's see here. Sure, let's do this. And instead of loop instruction, do the same. So we've got the push EX, pop BBX. Gonna call subroutine. We're gonna have to put that label in there. We're gonna XOR EX1. So we're just toggling that deck, and then that's our loop instruction essentially there. In fact, you could literally just replace that with the loop, right? Like there's no reason you couldn't just put that loop thing back there. This is just like a different form of what that loop could have taken. Then we've got that same thing, and now let's actually get this assembly. And I don't think yet, let's get rid of that. Right, or no, we want, yeah, we're gonna put that, the original code. And actually, I don't think this will matter. I think you can have extra white space at the beginning. It's not really gonna impact that stuff. So let's just let that go. Okay, do the same thing, make a function. And the one thing too that I like about this. Oh, what was that? Something's making
Joaquin
noise.
Ramirez subscribed to the channel.
Oh, I got alerts. A subscription. Thank you, whoever it was that subscribed. I forgot I changed my audio settings over on my laptop, but I think I've just not noticed that before. I need to set up the alerts so I can actually see them. I think it probably shows up on Stream Elements, but let's see. Can I do it here? There we go. Joaquin, welcome. Thank you for subscribing. I need to configure that better. Okay, so we've got our loop right before we're calling this garbage function, and we can now like look at that garbage function, and we're going to see this is actually, Binja is showing you this as a fall through. It knows it's already a function there, and it's going to go run that code. And we didn't even put the we did put the return. That's right, there was a return, which was the return of that function. Well, it's the return of that function. Which actually, that's a good point. This return 0 is never going to get executed. Actually, wait, that's weird. No, this is terrible and broken. It will be wrong, right? Because this push here. No, I guess that's fine. Right? Yeah, so it's just going to push and pop the same stuff here. I guess it doesn't really matter. Just this return is going to override this return here. You're not actually going to get a return 0 necessarily. You're going to get, or you might, but it's a coincidence, right? You're going to get a return from whatever EAX is, which is going to get saved. But what was it? Yeah, it's whatever it was up here. So the return value with this code is not actually return 0 because you're not going to hit it. And you can kind of actually see that because if you look in the code, it's going to fall into this function and then return from here, even though in the original, well, actually here, if we assemble again, if we look at this, yeah, the original code member had that return 0 down here, which is really just going to do like, right, and the C said return 0, but we're just going to do the equivalent here. Also, I guess I was doing this as 64-bit, but this is really 32-bit. Not that it really matters. It should be pretty similar. So let's actually switch that and get it correct. It might throw off some things. So let's close that file. All right, so now this one, if we go into linear view, we'll see how we're going to fall into that. And this is actually a really interesting point. This is one of the differences that we're going to see between Binary Ninja and other tools, where Binary Ninja literally doesn't even disassemble this code. So even though it gets compiled in, the reason why is because Binary Ninja knows it will never be executed. It can't be executed because this return here, intentionally or not, I'm not sure if that was the goal, like this final return you can't get to that, right? The only thing you're gonna return here, and your return value is actually going to be that EAX from up there. And actually, I'm curious. So this is a fun chance to show off like current function dot get reg value at here EAX. I don't know. Okay, so because this is a tail call, it's going to show up as entry EAX. Yeah, that makes sense. So what I would do is I would actually have to look into this here, and from this address, I could do the same thing. Like, do you know what EAX is? It actually doesn't know what it is. Is it because, yeah, I was curious if basically this value is going to get propagated down. Oh no, that's true, because this XOR is going to toggle the low bit of that number on and off every time it goes through this loop. And I think because this call here, by the calling convention, Rax actually, yeah, so Binary Ninja says, actually, I don't know what EAX is going to be because every time we call into this function, maybe something's going to happen. Now we can look at it and we can see, yeah, there's not that much stuff going on. And because it saves those values, it's not actually going to impact EAX. In fact, here's another fun toy. I like this. All right, so also let me turn off tooltips because they drive me bonkers. I point with my mouse a lot and I don't want those tooltips to show up. So I added that setting a while ago. So yeah, if you like hover it, you don't actually get that. All right, so because this function is, if I actually right click on this function, I can do edit function properties. This is a new feature. So if you haven't seen it yet, inline during analysis says, and this was originally implemented, the first version of it was implemented as a part of our workflows kind of system, where it was a prototype for modifying the analysis flow. It's a really powerful tool that we're still kind of figuring out and adding more pieces to it, but it's going to underpin a whole lot of new features and capabilities. It's really, really nice. It lets you totally change how all the analysis happens. But there was an example that would let you inline a function, but it was a little clunky. You had to like use open with options and specify a workflow and then set the function, and like it was just a little more awkward than it needed to be. And so this version of it, this variant of it, you just literally check this box and it will tell Binary Ninja, look, this is a really small little kind of like leaf function. Every time it's called in anywhere else, inline it. Actually just pull it into the parent function and add all its code there. And so if we do that and we actually switch over to like IL view, now you'll notice, so normally when you go from like disassembly to like a low level IL view, it looks exactly the same. So for example, if I switch over to this one, or the simpler version, I just hit I, it's almost 1-to-1, right? Because disassembly and low level IL are basically the exact same thing. However, here, if I switch over, it blows up because it's inlining that other function. And so here's the test. This is what I want to see. The loop might still be messing it up. Oh no, the loop is almost certainly still going to mess it up. Yeah, and the reason why is because Binary Ninja's value set analysis doesn't predict loops, right? It doesn't try to analyze, well, there's a loop and it's based on this counter, and that counter started at 5, and therefore it's gonna be called. Actually, is this greater than or equal to, or is it what's it comparing? Hold on, let's check. If temp d is not equal to, so yeah, ECX, if it's not equal to 1, so if it's equal to 1, it's gonna fall through. I thought it was. Oh, was it really? Oh yeah, yeah. Okay, let's look. What was the assemble command? I thought it was higher, but yeah, if it actually checks for um, J and E, that's jump not equal. So I would have thought, oh, yeah, we're just, yeah, J and E and J and Z are the same thing, right? So it's the same as, yeah, I know what I mean. Like the inlining, it's really nifty. I don't think it actually helps me here, unfortunately, because the loop itself is going to be the problem. But if there was no loop and it was the analysis might still not have been able to like handle the call because our just in general, the way our program analysis, the way we track things in the binary, we don't try to propagate things through calls. We have to treat them as kind of black boxes because if you don't, you get what's like called state space explosion, where like you're trying to analyze everything and actually have analysis that follows through every function. It just doesn't scale very well at all. And so we always treat each function as a black box and say within this function, what do we know about the values and how they go through it? And two of the things that can throw it off are one, a loop, right? Because it's not actually tracking how many times it goes through the loop. And two, if it calls another function, it doesn't say, oh, actually, except in very few cases. There's a couple of basic cases, and we may actually expand that now that we have this inlining capability. But in general, it doesn't try to track like what happens in the function because again, it could go off forever, and so it's really hard to do that perfectly. The one case it does handle is if that function literally returns a constant. There is actually a separate little part of the binary engine analysis that's like, oh yeah, by the way, this code all it does is return a value, and so it will just replace that call with just loading that value essentially. So that's one thing that it does work across functions, but usually it's just safe to say binary ninja's analysis does not work across function boundaries. And if you want to like automate it, you can do that. You can build that up, but you have to scope it down. You don't do it across the whole big program because you'd run out of memory and CPU real quick. So yeah, the thing I was going to try is not going to work anyways, unfortunately, because I was trying to confirm. Yeah, it's not going to work anyways because of the loop, but just for kicks, let's mess with this. Well, while we're in the middle of, while we're in the middle of this anyways, let's go back to the assembly. And I think if we just, let's just nop that instruction. So I can hit E, if you're not familiar with patching, it's really nice. Just hit E and type nop, or right click and patch and say never branch. If I did another instruction, never branch is the same exact thing as nop, because obviously if you nop a conditional branch, it just does that. So if I do this now, yeah, actually I can look at it right here. You can see in the disassembly it's annotating, but it's just literally telling me I know exactly what this value is, right? So this is another thing that Binary Ninja does that no other tool will do, is we have two data flow systems internally. This is just our constant data flow system. It's very fast. It's always running. If there's just a constant value and some math happens to it, it gets pushed into the stack and pop later. Like it's just that value. It will actually track and know that value. And so you can actually see the return value if we just disassemble or decompile this. Like this whole function is a return of a constant, right? That's exactly what that's going to do. So that's really cool. That works really, really well. But the nice thing is you get all of these annotated variables at all other layers of the IL too. You can actually do it through the IL system and see all those values just as constant there. So that was kind of nice. Again, I totally didn't plan all this in advance. I actually am doing this for the first time. So we're figuring it out together. I was hoping this would be a pretty good example for Binja, and I think so far so good. So yeah, so that's really nice. We can inline that function. I still think this is the person who made this. I don't think they intended this to actually be above the return, because it kind of doesn't really make any sense that return is going to be called. But anyway, it does mean if they decompile this function, if IDA was tracking it. Actually, I'm curious. Do they decompile it? Or do they only show disassembly? I think they're mostly focusing on disassembly, but I'm really curious if they hit F5 or if they have the decompiler in this. Bandicam. All right, I think they're just running this in debugger, looking through it. There's no. exec ass assembly, exec assembly. Yes, yes, clearly that's what they're talking about. Execute assembly. Okay, so all right, so that they're just kind of again. I think this is nice to like they're giving people kind of an intuition of what the stuff does. But now they're talking about opaque predicates, and I've talked about those I think a couple times on stream. It may have been a little while. Um, so I'm actually curious in chat how many people have heard the phrase opaque predicate before, and how many have not. Um, and if you did, was it our blog post? So that was the blog at the end that I mentioned. They linked to where we talked about it. I had never heard of it until I guess the job before this one, where I met some Peter, who wrote a blog post when it was we talked about it there. But the idea of like an opaque predicate is it's like it sounds. If you think of it's a weird one, but like opaque, of course, is something you can't see through. It's like occluded or blocked or like not transparent. An opaque predicate, and a predicate is in this context, we just mean um, like the argument of a condition. We mean we're gonna make some branch, and there's gonna be a condition that we're gonna check, and we don't and the tool won't necessarily know which way the branch is gonna go, but the compiler does, if that makes sense. Let's look at an example. It's probably a little bit easier. So they've got this program. They're just assembling it. Yeah, I don't think they're doing any decompilation in it. But now they're gonna take it. They're gonna add some garbage code. So this I do need to, well, I can just compile the code first and then patch in some stuff maybe, but um, so they're loading the binary up. Where did they, I didn't even see where they patched it. Where's the patch? There's no assembly in here, is there? No? I think they're still just showing the normal operation and how. All right, there's just extra branches, sure. Oh, bogus loops. Oh, they didn't add disassembly assembly instructions. They just added. Oh, y'all going quiet on me. Am I getting boring talking about opaque predicates? Nobody wants to admit whether they knew it or not. Um, the I think when they say garbage code, they mean just these loops. Okay, yeah. So they're just talking about like let's just put some extra. Sure. Um, I want to know. Actually, I'm curious. So let's try this. Let's try a few things. First, I don't know if this will work. I'm gonna try because we don't. Um, there is a compile. Yeah, that was right. There's a compiler built into Binary Ninja, and I don't. Studio and string.h are not found, but I think that might not be required. I think the minimal libc might literally just work. Oh no, strc span. Okay, is not there. Hey John, thank you for replying. At least, have you heard of opaque predicates before? Um, is the question of the day. Stir CSPN. Actually, don't know. Stir CSPN. Get the span until character in string. So it's like a matcher. Okay. I'm a little surprised. So yeah, so this is what I'm trying to use is scc.binary.ninja. It's built into Binary Ninja to let you compile stuff. And it does have it does have some string functions, but not that one apparently. I appreciate you saying though. Thank you though for replying. Everyone else has gone quiet. I mean, nobody wants to talk. They're just all listening. So no worries, no worries. I'm happy. That's a good answer because it means that I get to explain it. So yeah, in this case, we haven't seen opaque predicates yet though. Like in this blog post, I'm waiting. And where to go? I got too many tabs up. Let's close some of these down. Synthesis. There we go. Hands. Nope. That's Goomba. Small tail. So we haven't seen. This is not an opaque predicate here. This is just like garbage loops. That's a good question. Can you add custom headers? Welcome, Ryan. No, hey, listen, better late than never. Welcome. Let's actually do this. This is a fun trick that not a lot of people know. We've been debating for a while whether we should leave it like this, but SCC is also just a command line tool. So yeah, not in the UI, but in the command line, I think you can specify includes. to SCC. I wonder it. We don't use SCC a whole lot though. I will admit. It is not always the most robust tool just because we haven't kind of kept it up and used updated a lot. Although it should certainly handle this. But anyway, I'm going to put back just for ease of doing this. I'm going to put that back and what are we going to call this? exec.ass.c. Just to follow the naming convention, exec assembly, and let's keep having to turn off my screensaver to keep chat up. Oh no. What's the build root essentials? Build essentials. Yeah. All right. Clearly, this is a fresh VM that I haven't done anything on in a while. It feels good though to have a fresh VM. Oh no. All right. Come on. Probably have some old packages to install too. All right. There we go. Let's get that going. So just to catch you up, Ryan, we did a little bit of news brief at the beginning. We talked about, I was going to stall, but it installed too fast. We talked about training. They talked about the user survey. We talked about the 3.0 release. Okay. Oh, cool. There we go. All right. So our little snippet works. Let's open up the binary. Yeah, I was curious if the dead code elimination would see these loops as side effect free and remove them, and it did not, which is not too much of a surprise. However, I'll show off something else nifty that I like to do, which is if you are in high-level IO linear view and you hit Control Shift B, as in Bravo, and you search for patch convert to NOP, and I like to bind this to the delete key. This doesn't always work, but it's a cool party trick when it does. There's like this for loop here. Sometimes you can just delete it. Oh, no, it didn't work. Okay, patch, convert to NOP. Well, worst case, we can come back over here. So I hit delete. It didn't work right. NOP. Patch NOP. Oh, no, that's right. Okay, so that makes sense. I forgot you also have to do, because it's a branch, you have to make never branch go to the same hotkey. That's right. Okay, so never branch. And you can bind that also, because it's actually the same action, it just changes its name depending on the context, right? Patch goes away and that shows up. So, okay, now if we go back to this, I think we can take one of these loops and like literally hit delete on it and delete on it. You can literally just delete code like that. I love that. So if you want to clean up your disassembly, and then you can be like, yeah, these variables are no longer used, so div store elimination and allow it. You can be like, yeah, like go away. That one already is allowed. It didn't go away. Interesting. Div store elimination. Oh no, okay, there we go. I must have misclicked before. Yeah, so you can literally just remove that code, like, and you just don't want to see it. And it patched ironically, it actually patched the original binary too. So if we switch over to like disassembly, you'll see there's some NOPs. There's like a partial instruction. Like it's got pieces of dead code that it removed. And we could save this and we could run it and it would just not do those. So actually, let's do that. Let's modify, let's save as file contents, and we'll call this remove loops, right? And then yeah, so it still works, right? Illegal operation detected, deleting code. You are hacksaw, must be eliminated. So that's a fun little trick there, while working on this little like obfuscation. So if you're wanting to kind of clean up some of those code, and some of the actually that's another one. Binary Ninja will a lot of the time just do some of the stuff for you. It will just remove things, which sometimes. Oh man, I missed his time for Be Real. Hold on, I gotta take my Be Real here. This is very important, everybody. So say cheese, everyone. Cheese. Okay. Welcome, Valgrind. Joined just in time to catch the Be Real picture. I didn't actually have chat up on the Be Real, just so you know. Um, it's mostly I have a few actual adult friends on it, but it's mostly my daughter's friends, which they think it's hilarious that her dad tries to be cool. And I'm actually late for our time zone too. So all right, so we've patched the binary. Dead code elimination. Yeah, and a lot of the optimizations will just do this stuff for you, especially these little snippets that do some obfuscations. All right, so we get the loops. Yep, we know. Now let's look at one more interesting example. Useless arithmetic. Okay, that looks like just a function taking some code. So this, like, they refer to the opaque predicate blog, but they never actually... Wait, understanding opaque predicate. They never actually say anything about opaque predicates. What is it supposed to do? Adding a bunch of useless loops and subroutines. Okay, so I disagree with their explanation of opaque predicates. I think that's actually wrong. Welcome, Hevard. Welcome, welcome. I actually disagree. So I think the blog post here is wrong, and I think what an opaque predicate is actually, you know what? I can show you because we have an example. I'm pretty sure I've run this on stream before, but we're gonna do it. My pet peeve, by the way, is if you... Oh, you are actually late. That is quite late for your time zone. Thanks for hanging out with us. If you install the opaque predicate patcher plugin, that's a mouthful, in the plugin manager on Binary Ninja, and then you open your plug you actually go to where it's installed. If you go to your user folder, which is .binary ninja on Linux, there's a couple other paths in Mac and Linux, or in Windows, it's in your user docs. But if you go to the repositories folder, and then this is an official plugins, you can see the opaque predicate patcher gets installed here. Please, you make my life so much better if you include example plugins, or example files with your plugins. So I'm going to open, for example, Hello World normal, and I'm going to open Hello World opaque, and there's even a make file there. This is super helpful when you include an example of your whatever your script is supposed to do. So here's like the program. It just calls hello world, and this is obviously like some string print. Turns out this is a printf format string variant. I think it's the SCC built-in one. So I think this binary literally used. Let's see, repositories, official plugins. That. See the example cats. I think the makefile did just use SCC. Yeah, it did. So it used SCC that actually has a command to trigger anti-disassembly and opaque predicate patching as one of the things it can do. Or no, sorry, the anti-disassembly is opaque predicates among other things. So this is just printf, right? Like we can just name that. We can experiment that and modify the string to put like %s and then add another argument or something to it and modify it to run it. But if we look over here at the opaque predicate version, we see that sort of, but then we see a lot of other garbage. So it looks like it's the same or similar-ish up top. In fact, are the offsets even the same? What is this? The offset here. This is, yeah, 44F8. I mean, it's different because it was recompiled differently. But anyway, but what we can do is the opaque predicate patcher will go through and it rewrites the binary, and it's now the exact same thing. But let's undo that. So let's close that and redo what it actually did. Open up the opaque one, and let's look at the disassembly. So instead of looking at the decompilation, all right, we've got a move, we've got an add, and there's a continuation, which means that there's like a branch back into the middle of this code that's like splitting the basic block. But where does that branch come from? I don't know. I don't see it here. I could go back and look at cross references. We can see, oh, there's a jump here. So we can see a bunch of jumps that are splitting this code up. And then here, like these are all different basic blocks, right? Like this is a really good way to look at it. And this is actually better for graph view disassembly, I think, where you see there's a whole bunch of these branches. And like this here, that's a good example. This is what I think of when I think of an opaque predicate, right? This is a branch. And this is obviously garbage. Like just looking at this, you can tell that's almost certainly not real disassembly. And This one here, on the other hand, so this path, however, looks normal. And if you look, it says jump not equal, and then binary ninjas be like, by the way, uh, it's always going to be 0. It's never going to be non-zero. It says this thing that it's checking is just hard coded, and it knows this because it knows what the value was here, and it knows what this value was here, and it knows the result then. Um, Wait, is 0? No, it's not 0. It is 0. No, I think this actually means the result. Hold on, the result is 0, which means jump. Oh, sorry, right. Jump not 0. It is always 0, and so it's always going to go this way. Yeah, and we can double check that, right? So let's do the get current. Actually, we can literally just do what we were doing before. And was it what EAX is the same variable? Yeah, so it's telling us that EAX is a constant 0, and we can verify that by just doing this plus this, and because it's Python, we're going to get like 1 0 0 0 0 because it's not going to roll over. But so if we do that in hex, we should get 1 and a lot of zeros, right? Yeah, but obviously in a 32 register, it's just going to zero it out. So this is never going to be taken, and this is what I think of an opaque predicate, where you're not supposed to be able to predict or know where it goes. Oh, that's funny that Tim's obfuscated example is actually some malware. I mean, that makes sense because that's kind of what his plugin's for, but that's funny. Don't accidentally trigger GitHub malware alerts or do that. But yeah, oh, right. So I kind of get a little distracted. I love it when people put examples in their plugins. It makes it infinitely easier for me as I'm testing plugins in the Binary Ninja plugin manager. Like if we remove some APIs or change APIs, I'll go look for plugins that have it and I'll want to try to test them. But if it's like some architecture and there's no binary format, or if it's some like, deobfuscation plugin or detection and there's no samples, like I don't know what it's supposed to do. So I love it when people include examples with their plugins. It makes my life easier. But I think it's just easier for people who want to check it out when there's like, you give them an example file, they can see what it's supposed to do as a test. And it helps you for like having testing, right? Like, so it's just valuable in general. Oh man, it's almost 6. All right, so let's go back. Let's go quick. Like I said, I'm gonna go see a basketball game. I don't want to miss it. So let's look at the rest of this. Yeah, so I think the opaque predicate really is about like these branches, and the important part is one side of the branch is garbage, bogus data that's going to cause your analysis to get messed up, right? You want to send this down like some bogus route that like makes the decompiler or the disassembler just go crazy. So that to me is what I think of when I think of opaque predicates. But yeah, I mean, I think that's basically it. We saw everything that this blog post mentioned. There is one other trick that they didn't talk about. I don't think, let me search. Did they talk about misalignment? Mistake, misleading. Okay, I think instruction misalignment is super interesting. So the last time I checked, so this sequence of bytes, for example, if I just assemble that in 32 bits, is a jump and then an inc EBX, right? Except like you'll notice that it's this FF is here twice. So it's actually jumping into itself. It's a jump -1 and a x86 jump was from the end of the instruction. So it's going to go back 1 byte and the next instruction will start at that FF. And an FFC3 is an inc EBX. However, just a regular C3, of course, right, is a return value. So if your disassembler is a recursive descent disassembler, or is a linear sweep disassembler that can't handle like these misaligned instructions, it will see this as a return instruction. It'll first analyze, oh, there's a jump, and then just go to the next byte and be like, oh, and that's a return. All right, my function's over. It's done. When it's clearly not, because this is not a return. It's just abusing misalignment. And I believe IDA detects this and doesn't break for this. The last time I checked, though, if you literally just did a different weird offset, like if instead I just do jump 04, oh no, jump byte. No, that's fine. It can be a long. No, let's do jump byte x04. I don't remember the size. That's sure. Oh, that's funny. 4 is a bad number because yeah, that's why I padded it out. Let's just do 7. Do something weird. All right, now let's just assemble it. Now we get all this again. So let's jump. And let's just do a bunch of nops. And let's figure out where. Let's just put here a ret. Or actually, let's do Um, let's do a jump -1, or no, let's just do jump 0, 0, and then we'll patch it in place because I'm lazy. Okay, so this jump short here, nah, I want that to be EBFF. All right, so now I've got that same little short jump, but what I want to have to do is have this one land on byte 7, 8, 9, right? So we're going to actually change this to 9. Oops. 9. FF. Oh, I forgot the C3. No wonder it's not working. And if I put, because FF90 is not a valid instruction, but FFC3 is a valid instruction. So now we jump, there we go. So now we jump EBX. And I believe, I'll have to test this, but I think that IDA doesn't actually deal with this case. They only dealt with the case where it was like specifically EBFFC3 or maybe EBFF, jump -1. But if you just jump forward a couple of bytes and then land mid-instruction on something else where there was what could have been interpreted as a return in there, it will actually, we probably have to use something else besides EBFF because it might pick up that pattern exactly. But just like literally any instruction that ends in an FF such that, oh, I should have just done like move EAX -1 or something. So like if I just do move EAX -1, there we go, that'll work. All right, so that's the same thing. So that alignment worked nicely. So now Binary Ninja knows it's not even showing me the disassembly of these bytes because they cannot be executed. But if you just do a straight linear sweep disassembly, you would be like, there's a jump, there's a move, there's a return, there's some nops, and you'd be wrong because there is no such thing as a return there. It is actually just an inc EBX. So I think that's a fun little bit of obfuscation too. I was hoping that they were going to get it too. But anyway, so yeah, I'm curious. Let me know if you tried that out and if Ghidra. I don't think I've tried that in Ghidra if it handles it. But it's a fun little bit of shellcode. So cool. All right, like I said, unfortunately, this is a little bit shorter stream than normal, so I gotta go take off. I'm gonna go watch a soccer game. If y'all have any questions before we go, though, any last Binary Ninja questions, let me know. We can chat about stuff. But yeah, thanks for hanging with me. Yeah, this was a good little side quest. So yeah, I'm gonna try to do a couple of these where I just pick different blogs where people have written things up in different tools, and we look at how Binary Ninja would have done differently or better or worse. I think this one was particularly good because Binary Ninja works really well with little blobs of shellcode. You notice even a lot of the stuff like just pasting some shellcode, making a function, start analyzing it, decompiling it, is very fast and easy. It's something that it's pretty good at that kind of binary slicing and dicing. So cool. All right. Well, again, thanks for hanging out. Appreciate everybody chilling. Like I said, we'll be back in at least 2 weeks, maybe next week. I'm not sure I'm going to do every other week or more frequently. It kind of depends on the schedule. But I appreciate everybody hanging out. And yeah, that sounds good. I'll talk to you later. Bye-bye.